Hello. So I hope my screen is visible to everyone. And am I audible?
The screen is not
Yes, sir.
visible, but you are audible.
Okay. Thank you. So yeah. So I had given you an assignment, and the deadline of that assignment is, I guess, today. And I have not received a lot of submissions. I guess 5 or 6 submissions I have received. I hope you will be able to complete the assignment by today. Any doubt in the assignment? Any issue? Any doubt?
The part B, question 1, I am not clear. Is it similar to the question in part A?
Just 1 minute. Let me open it. Part. Yeah. Yes, part B, question number 1. Okay, so this is a little bit different from this part A. So
Mm,
actually, in some of the colleges doesn't follow absolute grading system. They follow relative grading system. So in the relative grading system, what happens is they say that they have 100% students. So whatever the number of student is there, they are saying that that is 100%. So the top 10% students, whatever their score is, suppose at um, uh, exam of 100 marks, the highest scored was 40 marks. So whatever be it, so for top 10% students will be graded A. Next 25% student will be graded B.
okay,
Next 25 C, next 15 D, next 15 E, and then the last below 10 is F. So this percentage may not be correct. I have just given this percentage as it is. It depends upon college to college. So these may be incorrect percentages, but the concept is this.
okay. Now understood.
And I forgot to mention there should be one assumption here in this question, that there should be a minimum number of students. So suppose the strength of the class is 5. In that case, it is not possible to give relative grading. So there should
Mm,
be some minimum threshold of students. Suppose 20 or 25 students, then only this relative grading is feasible. Otherwise, it is not feasible.
okay, sir. Okay.
Any more doubt? All right. So we'll start. So actually, I couldn't prepare PPTs today for today's class because I am not well, and I didn't get a lot of time. So in today's class, I have just written the text over here in this notebook. But it would have been better if I had prepared slides for today's class, because today is more about the theory than uh, programming. All right. So pardon me for that. And last class I had left out some of the problems which I wanted to discuss. So I'll start with that, and then I'll move on to the main part of today's class, which is functions. All right. So before moving on to the problems which I wanted to discuss, there is one important thing which I forgot to tell you is strings in Python are immutable objects. So it may not make a lot of sense to you right now, but in subsequent classes you will understand what is an immutable object. But you can get an idea of immutable objects. Suppose I have assigned a string s is equals to hello participants. Hello participants. All right. So this is a string. Now what am I doing is I can index in this string. So suppose I am saying that what is the fourth uh, character in fourth, or element in the fourth position. So I can get it as O. So you can check 0, 1, 2, 3, and 4. So, Acha, by the way, those of you who has not seen or watched my previous lecture or was absent in my previous lecture and has not watched the recording, then it will be a little bit difficult for you to understand because I am taking the concept from previous lecture and then explaining it here. All right. So I'm saying that what is the element in the fourth position? So it starts with 0, 0, 1, 2, 3, 4. So it is O. Now what am I trying to do is I will try to assign some other value to this fourth position of this string S. So I'm saying that assign this fourth position, whatever the value is, assign suppose A. So suppose we want to assign A. In this case, it will not be possible. Why? Because string objects do not support item assignment. So it says that it just means that you cannot mutate a string in Python. If you want to mutate a string in Python, then you split the string over this side and then this side, and then you again concatenate it. So something like that you have to do. You just cannot mutate the string. You just cannot change the string once it is assigned in Python. All right. So this is an important concept, and you should know this. Any doubt? All right. So in last lecture, we have done this, talked about string. Then we talked about indexing in a string. We talked about slicing in the string. And we talked about few of the methods in string. If you want to know more methods in string, you can just go to python.org. So you can say Python string functions, and when you search, you will get a list of methods. Yeah, you can go to this Python documentation and you will get all the methods which are used in, which can be used for manipulating strings and do a lot of stuff with strings. There are many websites to go to. This is a good website, W3 Schools, and this Geeks for Geeks. So you can go and check. These are all functions. All right, so we will see what functions are in today's class. Yeah, so in previous class, we talked about three functions: upper, lower, and split. These were few important functions, and I wanted to discuss this because it would have been necessary for the assignment. That's why I discussed three functions over here. Then we talked about if statement. Then we talked about if-else statement, and this is actually branching in a code, and we are manipulating the control. So these are all control flows, the part of control flows. We saw an example, very small, minimal example. Then we saw that if we have more than two cases, then we can use if-elif-else statement in Python to create more than two branches in a code. All right. And then we saw that we can also nest more than one if in a block of code. All right. So we saw nested if condition, if inside if condition, or if else inside if else condition. It doesn't matter. Now, so this was class. So this was what we are talking about. Yeah. So in the yesterday's class, I talked about this, and then we said that we will skip this part for the time being, and then we'll come back. So today I am coming back to this. I'm saying that there are three numbers, and you want to get the maximum among the three numbers. What is the maximum number among the three numbers? So I have given two algorithms. So I would also suggest you to do this whenever you want to solve some problem. First, write the algorithm in plain English or in pseudocode, whichever you find comfortable. When you do that, you will get a very good idea of how to solve that problem, and writing code will be simple. So you will not fall into loopholes. So writing the algorithm first and then coming to code is better than just starting to code and then you will see what loopholes are there in the code. How it is better? You see, when you write in plain English, you can think about the higher level stuff first, instead of thinking about what should we write and what should be the exact keywords or something like that. So you can think about the cases which might happen and divide the cases and then see how the flow goes. So writing in plain English first is better. All right, so first I have written get the number from the user. Then so this is two algorithms which can be employed to get largest among three numbers. These are just two. There can be many other algorithms. These are the just two which I have written. So first algorithm I have written, which is only using if statement. It says that assume number one is the largest. So we don't know which number is the largest, and we have three numbers, num1, num2, and num3. And we are saying that suppose num1 is the largest. Now I am comparing num2 to the assumed largest, which is num1. So I am comparing number 2 with number 1, and we will store the largest among these two. So whichever is the largest. So if greater, so it says that compare these two numbers. You are assuming number 1 is the largest. Now compare second number with the first number. Whichever is the largest, store it. Now you check the obtained largest in the previous case, and then compare it with number 3, and then get the largest. Whichever is the largest, you display it in the result. So in algorithm 2, it says that get a number and compare number 1, number 2, and compare number. Okay, so this is not a step. I have written it, but this is not a step. Compare number 1, number 2, and number 3 to find the largest. This is what we are doing. So this is not a step. All right. Just a minute. Why have I written this? Yeah. Okay, so I have written this because I'll do if-else statement. So I'm saying that if number 1 and number 1 is greater than number 2 and number 1 is greater than number 3, then number 1 will be the largest. This is what we did. Similarly, we saw that number 2, I'll compare it with number 1, and also I'll compare it with number 3. Similarly, number 3, I'll compare it with number 1, and I'll compare it with number 3. So in these three cases, we will have one of the three cases as successful case, and then we will obtain the largest among the three numbers. So I have written the code over here, and then you will be able to see how it is getting executed. So you see I have given number 1 as 10, 50, and 15, and I am saying that suppose number 1 is the largest number, and I am checking if number 2 is greater than number 2 is greater than the assumed largest. If so, then update the largest value as number 2. If not, then we will move on. We will check if number 3 is largest, greater than the largest. If not, then we are having the largest number. Otherwise, assign the largest number 3 to the largest value. So if you execute this, then you will obtain the largest among the three numbers is 50. So was I clear what this code is doing and how it is obtaining the largest among three numbers? I hope it is not difficult. Any doubt?
No, sir.
Okay, thank you. So I'll go to the second code, and this is the second code. I have three numbers, 10, 15, and 15. So what I'm doing is I'm taking one number and comparing it with the other two. So I'm saying that we will first see if number 1 is greater than the other two. So we are checking that, and we are updating the largest. So here we are not assuming largest to be some number. We are saying that we will update largest only once whenever we get a largest number. So we check if number 1 is greater than number 2 or number 3. If not, then we don't have the largest or any assumed largest. Then we will see if number 2 is greater than number 1 or number 3. If number 2 is greater than both, then we have the largest. We don't need to see subsequent cases. That is why we are using if-elif-else statement. So either number 1 will be greater than the 2, number 2 will be greater than the 2, else number 3 will be greater than the other 2. So either one of these cases will be true. All right, and we will get largest only once. So we are not updating largest in subsequent iterations, what we were doing earlier. So this is not what we are doing in algorithm 2. So in algorithm 1, we are assuming that this is the largest number and updating the largest as we encounter more and more number. But in algorithm 2, we are saying that whenever we get the largest value, that will be the largest value. So we are comparing in that manner. All right. So this is another algorithm to obtain the largest in three numbers. All right. So there can be many more algorithms. These are just two simple algorithms to obtain the largest among three numbers. All right. So what we did next, we saw the example of how if-else condition may not be appropriate when it is dependent upon the user's input. In that case, we use loops. So when to use a while loop and when to use a for loop. So in for loop, you actually know the number of iterations, not explicitly, maybe implicitly or explicitly, but in while loop, you actually don't know the number of iterations. And in that case, while loop is more appropriate to use. Suppose you want to get an input from the user and the number of iteration depends upon the input of the user. In that case, while loop is used. We saw how it works with the flowchart and we saw a small example. And we also saw that while loop can also be used with else, but it is not important and we generally don't use else with while loop. All right. Now I have skipped one program here, which is saying that we want to get the we want to check if the number is prime or not. All right, so this can be done with for loop as well and while loop as well, but since we are talking about while loop, so we will solve it using while loop. So we'll go down and I'll just copy the code. This is the code. So have you guys seen the code? I had given you the code earlier, but we had not discussed. So did you get time to see the code? These are very simple problems to solve. And could you follow the code before I am explaining the code? So could you follow the code? Anyone who found it difficult to follow the code or this program, whatever it is, you can say that. Then it will be beneficial for me to explain in some other way, maybe. All right. So how many students are there? 12 students are there. All right. So I'm saying that I am not well, huh? So I may sound a little bit low. So excuse me for that, huh? So you see, when you want to check a number, which is if it is prime or not. So first you get a number from the user, or you just give a number. So I've just given as an input. So it can be otherwise also. And I'm saying that I'll check if it is divisible by any number between 2 and 1 less than itself. Because if a number is divisible by itself and 1 only divisible by 1 and itself, then it is a prime number. So I'll just iterate from 2 to 1 less than the number. That is why I'm saying I is less than number. So it will not go up to the number. So suppose number is 10. So it will not go up to 10. It will go up to 9. All right. And I'm saying suppose it is not divisible by any number. That is why I have given a variable is divisible as false. So this is an initialization step, and you are saying that we are supposing that is divisible false. What does it mean? That it is a prime number. So it is not divisible by any number between 2 to 1 less than that number. But we will update it when we get more information. So what we do is we check if the number, so we already have that number assigned to NUM, and we divide and we get the modulus at each iteration. So at each iteration we will update I. So we start I from 2. So this semicolon is not necessary. All right, I have given semicolon, but this is not necessary in Python. So you see, you assign I as 2 and we are checking if 2 is less than the number. If it is so, then we will check if the number is divisible by 2 or not. If it is divisible, then is divisible will be true, and obviously then it will not be a prime number. All right, and we will check again and again until we have executed till number -1, and then we will check if is divisible. So what is if is divisible doing? So this is actually an expression which will either be true or false. Here it is not an expression, here it is a variable which will either have a true or a false. So if this is true, then this will be executed, and if it is false, then this will be executed. All right. So this is how this program checks if a number is prime or not. So we will enter a number, suppose 45, and we will see that 45 is divisible by 3, 5, 9, 15, and hence 45 is not a prime number. All right. I hope it is clear. Now we'll move on. We saw for loops.
Why we need to use that number -1 in while condition?
All right. So this is a concept of prime numbers.
Instead of having this number, maybe can also use number by 2 divided by 2 as well.
Yes, right? Yes, we can do that. This is a simple program. So you can modify this program a lot. You see, once we get is divisible as true, we need not check again, because we are just worried about if the number is prime or not. In that case, we can also introduce a break statement here. All right, I have not done it, but you can introduce a break statement.
No, not break statement. I'm saying instead of checking, for example, you enter a number 34. Instead of checking till 33, we can stop at 16 or 17, right?
You are
It
correct.
won't.
No, you are correct. You see, you are saying, you are giving an example of another algorithm. I am also saying
Okay,
another
okay, okay,
algorithm. Both
okay.
algorithms are correct, but yours is more efficient than mine. All right. See, whenever you write an algorithm, there is two things to worry about: if it is correct and if it is efficient. Mine is also correct. Whatever you stated is also correct. Both algorithms are correct algorithms. This is what we discussed in first lecture, if you remember, correctness of an algorithm. So mine algorithm is also correct. It will give you if a number is prime or not, and your algorithm is also correct. But this algorithm will take more time to complete, but yours will take less time. So yours is more time efficient, you can say. All right.
Okay, sir.
I hope it is clear. Yeah. So we can improve this itself. So you see, instead of checking till number -1 or checking number by 2, we can do that also, number by 2, but we can also do that if is divisible becomes true in any iteration. Suppose in 2, so when we divide the number by 2, suppose the number is prime. So I have given 32 as it is a prime number. So whenever it is divided by 2, is divisible will be true, and then we will break. So we can modify this algorithm in many cases and give a more efficient, time efficient algorithm. Because it is divisible by 2, then it will not be a prime number. All right. Yes. So I'll move on. So you see, we saw for loop, and we saw that this for loop is a little bit different from other uh, um, programming languages, because this actually iterates over an iteratable object. So S is an iterable object, and for loop is iterating over each character in that, or each iterating over each character in that iterable object, which is string in this case. All right. And we saw what range does. Then we saw for loop with else, which is not important. Now we saw one program was there which I did not see. So it is saying that display all the prime numbers within a interval. So this we will do using for loop. So we say that we will obtain all the prime numbers between 20 and 50. All right. So we are checking, and this range will give starting from 20 to index +1. So because we are saying that both are inclusive, so you include 20 and 50 both. So when you say range start, so it will start with that number but end with 1 minus the end point. So if the end point is index +1, so it will go to 50, because 50 plus 1 is 51, and it will go to 50. So it will iterate and it will check. So why I have given this condition, number is greater than 1, because 1 is neither prime nor even nor odd. So it is a unique number apart from 1. If that is the case, then we will check and we will assign. So for each number, suppose we are doing for 20. For each number, we will say it is not divisible by anything, and we will check if the number is divisible by a number from 2 to 1 less than that number. And if it is true, then we will assign is divisible as true. And if it is not divisible, then we will print the number. So this is a little bit involved, and this are not important. I'm sorry, actually I have copied it from somewhere. No, yeah. So what it is doing, it is taking number in the range start index to stop index. All right. And for each number, it is checking if it is divisible by any number from 2 to 1 less that number. If it is so, then it will not be a prime number and it will not print it. If it is not divisible by any of those numbers, then it will be a prime number and it will print it. All right. So these are you see, you have to see the flow of execution, and then you will get what the program is doing. All right. So if you have any doubt in this program, then you can ask me. Any doubt?
No, sir.
All right. Anyone else? In case you feel that you're not getting the hang of it or you're not getting what it is happening, you can stop me. I'll explain in more details. All right. So we talked about break statement and continue statement, and what we were talking about is we can improve this code. So you see, I have given a break statement here. So I'll just copy this code and we will just follow the code. So I am just taking one number from the user and I am saying that is divisible is false. The same code which we saw for while loop. All right. And what we are doing is we are saying that if the number is divisible, so if this is equals to 0, what it means? So the remainder is 0. If the remainder is 0, then the number is divisible by I, and in that case we'll break out of that loop. We know it is unnecessary to check if the number is then divisible by any other number or not. If we are only worried about to get if the number is prime or not. In case we are worried about the number of factors of that number, then we need not break. We should not break actually. So what am I saying is, if you are trying to get the factors of a number, then you should not break, because you want to get what number divides that number. But since we are only worried about if the number is prime or not, in that case we will break out of the loop and we will say if a number is prime or not. So we will enter, suppose 7 is a prime number, and it will say 7 is a prime number. All right, is it all right?
Yes, sir.
Thank you. So yeah, so this is all for what we had skipped in previous class. Now we'll move on to today's class. So yeah, over here. So you see, in first class we talked about abstraction. All right, I'll just zoom a bit. In first class we talked about abstraction, and we are talking about abstraction again in today's class, because in today's class we will see we will talk about functions. All right, and we saw that functions are actually abstractions. All right, now you see I'll just read what I have written because it is important. A good programming style would be not to necessarily so what, when you write a code, it is not necessary that you write a lot of lines of code in it. You should instead add more functionality to the code. So what your program should do is, it should have some features in it. Some blocks of code can be reused again and again, and this is what abstraction says. So you are not worried about the lower level details of those blocks of code which can be reusable in subsequent part of your program. All right, so this is a good practice to break your code in parts, and if you can, then make functions with that code so that you can use it later in your code, or if you have to update that code, you will only have to do it in one point. All right, so repetition of code is not a good practice. So function helps us achieve decomposition and abstraction. So what is decomposition? All right, so we know what a function is. We told you this that you can think function as a black box, and you are not worried about the lower level implementation. So how it is doing, you are not worried about. You only know what the inputs of that functions are, what the function will do, and what will be the expected output. You don't know how the function is executing the or solving the problem. You just know what the inputs of that function are, what is the expected output, and what will the function do with the output. A little idea is needed because you have to use that function. So it's like a user manual. You know what the so suppose you have a laptop, so you are not worried about how the processor is working and how the power is being sent from one unit to the other, but you know overall how to use that unit. In this case, it is function. All right. So decomposition is the process of creating structure in your code. So we will take a real life example. Suppose you are assembling a model kit. Suppose you have a model aeroplane, and you are assembling it. Then you can have this following decomposition. So you can check the inventory before starting. Review the part list in the model kit manual. So if you have those parts or not. Now in the subsequent step, you can divide the model kit into sub-assemblies. For example, if you are building a model aeroplane, you might have sub-assemblies like fuselage, wings, or landing gears, tails, etc. So what you are doing is you have to assemble the whole model airplane. So you are saying that we will make sub-assemblies. So for the wings, we will do assembly separately. For the tail, we will do the assembly separately, something like that. You will follow the instructions step by step. If there is some painting or detailing, you will do that again, and then you will go to final assembly and then quality checks. So this is a decomposition of the problem. What is the problem? Assembling a model kit. So similar to this, in programming, you can decompose your problems into modules, or sorry, you can decompose your code into modules, and these modules are actually self-contained units. And what it helps in, so it helps in facilitate the code. So if you will know that what this module does, and you will not be worried about, so if you know that module is working correctly and you have a problem in your code, so you will not go through that module because you know that module is correct. So it will facilitate in the division of code, promote code reusability. So suppose you have a module and you know the functionality of that module, so you can use that module in subsequent part of your code. All right. Or if you don't have the module, then you have to rewrite the code of the module again. I'm sorry, just 1 minute. Hello. I'm sorry. Yes, so we are saying that promote code reusability. Then it says that maintain code organization. So what we are talking about, you will know what that code does and you will not worry about if the code is correct. All right. And ensures code coherence. So coherence means that it will coordinate with other parts of code. So you will know that this part of your program is calling that module and that module is calling another module, and it will promote coherence of your code, togetherness of your code. All right. So this modular approach enhances code manageability and readability while encouraging efficient reuse of code components. So we can think about, so it is think of actually. So we can think of modules as mini programs, all right, and we can achieve decomposition by using functions and classes. So in today's class, we will not talk about classes, but we will talk about functions, all right. So you can think of these modules as functions in your program, and these functions have some features, some functionality, and you are using those functions to execute or to perform the operation that function is meant to do, all right. So these are just general overview of what a function is and why using functions is beneficial instead of just writing the code in a whole stretch. All right. So we'll see functions. So before moving on what a function is, just we'll see the syntax. So you see, this is a syntax of a function where we first write def. So def stands for definition, and it is a keyword in Python. All right. Then we will give the function name, and we will have parentheses. Inside the parentheses, we will have parameters. So what is a parameter? You see, when you call a function, that function has some input. So these parameters are kind of input to the function. You are passing some value to that function. All right. So these parameters will capture those values and will use in this function, and whatever the function does, it will do it. All right. Then the function has something called docstring. So docstring is actually a description of what the function does, and we will talk about docstring in today's class in a little while. Then the function has body. So instead of statements, I'll call it body, function body. All right. So what is a function body? Whatever the function is meant to do is inside the function body. and the function, inside the function body there is also something called a return value. So what is a return value? So every function in Python returns something to whoever the function called. So suppose my program has a variable which is calling that function. So we will see what it means by calling a function. Now when the function has done everything it is meant to do, then it will return something back to whoever has called that function. That is what is called a return value. All right. So you see, we see that this with an example. All right. So let me write an example over here first. Then we will move on. Otherwise, it will just be abstract knowledge. So let me write a function here below. So suppose we have a function which is getting the twice of a number. All right. So we'll get a number x, and we are saying that. So we are defining a number. So def is a keyword and twice is the name of the function. X is a parameter of that function. So this is the input to this function. And I'm saying that y is equals to 2 times x. All right. So I'm just multiplying 2 with whatever the input is. And I'm returning. So this is what return says, retur, and return y. All right. So you see, this is the def keyword, this is the function name, this is the parameter, this is the body, this two things is the body. We have not written any docstring here, but we can write a docstring. Suppose I'll write a docstring. So docstring is always written in 3 inverted commas. All right. So you can say that this function returns twice the input value. All right. And you can say the input is actually any number. That's it. All right. So when you execute this code, you see the function is being executed, but nothing is being returned because we have not called this function. You see, this function has been defined. So Python knows about this function called twice. So it knows that something is there, some function is there whose name is twice, but nobody has called it. So this function is not executed yet. Now when you call this function, suppose we are calling tw, so you say that z is equals to, so how do we call a function? You write the function name and pass the value. So you have to match the number of parameters the function has. You see over here the function has only one parameter x, so you have to give one parameter. Suppose I am passing 3. Now you see when I pass 3, this function execution has been done with the value 3 passed to this function. All right. And z stores the return value of this function. So when this function execution is completed, it returns the value, this value y, to z. Now when you print z, you will see z has a value of 6. All right. Now how it is doing so, we will talk about. I have something called function scope. Then we will see how, what is the scope of these variables. So what do I mean by scope, and you will see in subsequent time. Just give me some minute. So you see this is called function definition and this is called function call. All right. So is this clear? Function definition and function call. Any
Yes,
doubt
sir.
in function? So I'll request you to write a function which checks if a number is even or not. Do now. If a number is even or not. It is easy. All right. So I have written some docstring for this function. So it will be better if I copy the docstring and write it here. So write a function which actually takes, so which checks if a number is even or not. So it takes an input and it checks if a function that number or that input is even or not. And what it returns true if the number is even and false if the number is odd. All right. So you want, so I'll just give you some hint. So you want to define a function is even and you want to take an input. So suppose the input is x and you do something here. So you do something here and this returns true if the number is true and false if the number is false. So you check is even, and when you pass some number 4 suppose, then it will return true if the number is even and false if the number is odd. All right, so do this. When you have done, you can unmute yourself and at least inform me you are done. So how do you check if a number is even? Thank you. So how do you check if a number is even? You just find the remainder. So x modulus 2 equals to 0. So if this is true, then the number is even. If this is false, then the number is odd. So you can either assign it to a variable, say y equals to this, and return y, or you can directly write this expression over here. Right? You can just directly write the expression over here. So this is very simple function which checks if a number is even or odd. If it is even, it will return true. If it is odd, then it will return false. All right. Could you do it? Anybody here couldn't do it? All right. You see, why are we defining such function? We can always do x modulus equal to 0 and check if a number is even or not, because this will also have true or false. All right. But you see, this is a very simple function which checks if a number is even or not. What if you have some complicated things to check? Then that function will be defined separately, and you just have to call that function and the return value will say whatever you wanted to check. So suppose in this case, I wanted to print all the even numbers between a to b, suppose. All right. So I'm saying that for let me write a is equals to 2 and b equals to 19. All right. And I'm saying for I in range from a comma b plus 1, because range goes from a to b minus 1. So that is why I have added 1 over here. All right. And I'm saying if is even I, then print I comma is even number. You see, it is so much easy to read. I'm saying that if I is even, then print I. You're not worried about how this is even working. You're just not worried about. You can use it again and again in your code over here or in some later part of your code. This is why using function is important or necessary, you can say, or beneficial, you can say. All right. So this is how we can use function for our benefit. Is it okay? So how many of you couldn't understand what this did? All right, we will go there. Just hang on a minute. All right, first I have a little bit things to define. So you see, whenever we view function, we can view it in two aspects. Either you can see that you are developing that function, and in the other aspect you can see that there is already a function defined and you are using that function. All right. So in both cases you are not the end user. End user is someone else. You are either using that function for your own program, or you are defining a function for your own program. You can view function in two aspects. So I have said that a function can be called or invoked in a program. This is how a function is called. This is a function call. All right. And I have said that a function has a name, then a parameter. It has an optional docstring. You can either give a docstring or not. It is up to you, but it is always advisable to give a doc string. All right, the function has a body and the potential to return a value. So why have I written the potential to return a value? We will see in let me write it here only. So you see over here I have said that return something. All right, but a function may not return anything if you have not written. Sorry, I missed it. That is not what I meant. I said that a function always returns something, but in case if you have not given a return statement, then it will return none. All right, so I'll just show you. So suppose this is what I am doing. So I am saying that I am defining a function which is even 1. So I'll just change because this is different from the above function, and this function will not return anything. It will just print if the number is even or not. So it will first check y equals to x modulus, or just it will check if x modulus 2 equal to 0, then it will print the number x comma is even number. All right, now you see you are not returning anything. And now when you make a function call, you see this is being executed because you have called the function and passed 4. When 4 is passed over here, x has the value of 4. Now it checks if x modulus 2 equal to 0. In this case it is true. That is why this print statement is being executed. All right, and then the function returns something, but here you have not defined any return statement, so it will return none. So if you check w, the value of w will be, sorry, so none is actually, if you write like this, I guess none will come. Why the none is not coming? Just give me 1 minute. It should have none. Just 1 minute. No? Sorry. Yeah, so it is none type, so it is not printing anything. So if you print w, I guess you will get print w. Yeah, so you see print has a none, so it is a none type. All right, why it is none? Sorry, print not w. Why it is none? Because this is even, you have not written any return statement in this function. In that case, that function will return none. All right, so w is actually none. So this is what I meant, the potential to return a value. So you can either none. All right, so this is what I had to say about functions. Now we will go on to see, we have seen already, but we will see again. All right, so you see in docstring I have written some things that I'll copy, it will be better. So you see we have defined a function twice. You see we have defined a function twice. When you pass something to it, suppose you're passing 4, you get 8. Now in twice we have given some docstring. This is the docstring to twice. So you can actually get this docstring from twice. Why is it necessary? Because you are using, suppose, this function twice and you don't know anything about this function twice. In that case you can get the docstring from this function, and this is why docstring is important when you define a function. Suppose you are not the user of that function, in that case it will be beneficial for the user, not the end user, the programmer or the developer which is using that function, to know what are the inputs to this function, what this function does, and what are the return values of that function. You can get the docstring of a function by just saying print twice dot underscore 2 times, then you have to say doc, then again underscore 2 times, and this will print the docstring. So you see this is what I had written in the docstring. This function returns, I had not executed this, just a minute. Now it will be updated. Now it will be updated, and it is saying the function to double the number. So input is I, a number, prints a statement to indicate. So I have not actually printed I have not given any print statement here. So I can give also print statement. So you see I can just print a statement here. Print gets the twice of that number. All right. Now it will print a statement indicating the control inside the function. So this is just comments, so it is not necessary what I have written. So I had written it for my code which I have written in my this slide. All right. So this is how you obtain a doc string. So you see this twice function, we have defined this function. So, but you can also obtain doc string for the function which is predefined in Python. So you want to get the doc string of a function, suppose. So you see print is also a function. All right. And this is the input to that function. So you can get the doc string of print itself. You write print dot under double underscore doc double underscore, and this is the doc string of print. This is defined by the developers of Python. All right. You can also get the doc string by using shift tab. When you do shift tab, you will get the doc string, and when you expand this, you will get all the details of this. You see, you can just go through the details. So this is the doc string of Python. It says that value step. So we will talk about this step, what step is. We have already talked about this end. So this end actually has, if you don't pass anything, it has a default value of \n, which is an enter, and this is the doc string which the developers of Python has given for print. Similarly, you can use it for other commands or other functions also. So if you want to get the doc string of len, you type len and you press shift tab. So this is actually a function of Jupyter and not other editors. So if you are using any other editor like Spider or something, so then you will not get this. You have to do this print. So in that case, you have to do print len dot double underscore doc double underscore, and you will get the doc string for that function. All right. So we have already done this task. Define a function is even which takes a positive number and returns if the number is even and false otherwise. All right, we have already done this. Now very important concept will come, which is variable scope. Any doubt? Sorry, any doubt? All right, then we will take a, why is this happening? We will take a break of 5 minutes and we'll meet at 7 o'clock and then we will proceed. All right, let me check, there is some error in my side. For the time being, we will take a break of 5-6 minutes. We'll meet at 7 o'clock sharp.
Okay, sir. Okay.
Hello, am I audible? Hello, am I audible?
Yes, sir.
Okay, so you see, we will talk about something called variable scope. So when you see what the variable scope is, then you will be able to understand how Python defines the scope of that variable in different functions. So when you are passing something to that function, you see, you're passing a value to that function. Then where is the assignment done? What is the scope? So where you can use these variables. All right, so this is what a scope of that variable talks about. So before that, you have to know what are formal variables and actual variables. So formal variables in programming, a formal variable is a variable or a placeholder used in the function definition. It represents the input that a function accepts to receive when called. You see, when you are writing this function, when we wrote this function, we had written an input which is x. This x is defined for this function, is even, and this is when we are writing x over here, it is suggesting that it is a formal parameter for this function. Why formal parameter? Because when we define this function, so we saw the definition of a function. This is a function definition, and this is a function call. Until and unless you call that function, the function's body will not be executed, right? So whenever you define this function, this parameter will be defined, but it will be empty. It will not have any value. So this is why it is known as formal parameters. And whenever you pass this function, and whichever variable you pass, you can pass a variable also here. Suppose you are saying that y is equals to 3 and you are passing y. Y is equals to 3 and you are passing y. In that case, this y will be known as actual parameter, because this is the value which is actually passed to that function. So this is known as actual parameter and this is known as formal parameter. All right. I hope it is clear because it is important. What is the actual parameter and a formal parameter? Now we will see one example. Then it will be very clear how this works. So we will see this. So you see, I have defined a function greet. And what is the definition of this function? You see, it takes an input and assigns the value to a variable called name. And then it has a variable called message, which concatenates hello, comma, space, name and exclamation mark. So whatever is the value of name, it will be passed over here and it will be concatenated. So hello, space, then name, then exclamation mark. This will be the value of message. And then we will print message and then we will also return message. So the return value of this function will be this string hello comma name, hello comma space name exclamation mark. This will be the return value of this function called greet, and that return value will be actually assigned to, or not assigned to, it will be given to whoever the function is calling. So whoever is calling the function, to that the value of return will be given. So when we define this function, nothing happens, only the definition of this function is there. Now we are saying that name is equals to Alice, and you see this name and this name has same, it is same. This variable which is name and this variable which is name, we have given the same name to the variables, but actually these two are different variables, which we will see by the diagram. All right, so suppose we have given a variable the value Alice and that variable name is name, and we are passing this variable to the function greet. So this will be this will be actual argument or actual parameter. Now the value of this will be passed to this variable which is name, and then in that case it will be formal parameter. Now we will see with a diagram, then it will make sense. You see, this is the program and we have given a function definition. So when Python executes, it will make a function name called greet, and there will be some code inside it. It will not go through the execution of that function. That is why I have just written some code is there. but syntax error is not there. You should remember that defining also, when you are defining, there shouldn't be any syntax error. All right. So Python knows that there is a function called name which has some code in it, and it creates a global scope. So what is global scope? Global scope means throughout your program, this is the scope. So globally, you can identify this variable, this function greet. So wherever you write greet, it will know what greet means. Similarly, in the global scope, you have defined a variable called name, and you have assigned the value Alice to that variable. This is a string. So this name actually is global. You can use this anywhere inside your program and it will be recognized. When the execution comes here, Z, you see Z will not be created instantaneously. First, so this is a assignment operator and it will go from right to left. So first this will be, sorry, this will be executed. So what it will do, it will call greet function. So now another scope is created called greet scope. So you have two scopes, global scope and greet scope. All right. And in this greet scope, the execution of that function begins. All right. So you have two scopes now. Now it will go line by line. You see this formal argument name, the variable which I have given the value, sorry, just 1 minute, name, it will be assigned the value Alice. All right. And then message will be assigned the value hello comma space Alice exclamation mark. All right. Now it will print message. So this scope is actually in the memory. So I have not written print. So it will print in the output screen. All right. Now when it comes to return, then this value which is there in message will be returned to whoever called it. Who called it? This line called it before the assignment. So it will return. So this greet name will be replaced by whatever the return value of this function is. In this case, it is hello comma space Alice exclamation mark. So please understand what is happening. When the execution comes here, this will be executed first. So this will be evaluated first. I mean, greet name. So what is the return value of this function? You see, hello comma Alice is returned. So the value of this expression, you can say, or function call, you can say, is hello comma space Alice exclamation mark. When this is done, then assignment will give that value to Z. So that is what I have written. This value is coming here and then Z is being assigned the value hello Alice. And you see when this function returns its value, whenever the function returns its value, that scope is not there. It is just erased or removed from memory. All right. So this name variable and this name variable have different scope. In case you change this name variable here, the value of that name variable will not be changed here, because this name variable has a scope limited to greet scope and this name variable has global scope. All right. Is this clear?
Yes, sir.
Now you can visualize this using a very good website which is made by, I guess, MIT. I'm not very sure. Over here you can see. This is called pythontutor.com and I guess it is developed by MIT students. I'm not sure. All right. So when you visualize this, you see this arrow indicates where the control is. All right. And we can just see step by step how the control moves. All right. So this I have given an example over here for function definition. You can also use this for loops, if statement, etc., etc. All right. So you just see when I press next, the red arrow will move down. All right. So when I do next, you see when this green line comes, it says the line that has just executed. So this line has thus been executed and you have a global frame. So here frame is scope. All right. And you have greet there. The greet function is being defined, but whatever is inside it is not necessary. It is not executed yet. All right. Then the execution comes to this line number 6. Line number 6 is being executed and you see in this global scope name has assigned. So Alice has been assigned to a variable called name. So this is what it says over here. So this is the global frame. All right. And name is being executed. So green line is showing here and red line is being executed next. So when you execute this, you see Z is not assigned till now. Z is not assigned because first it will evaluate greet name. So it is calling greet, and when it is calling the function greet, in that case, one more scope will be created. That function scope, here it is called greet scope, and in that case, one more variable will be defined, which is name, and that variable will have a value of Alice. Next execution, when it is done, then message will be assigned this value hello comma Alice exclamation mark. All right, you see message, this is executed, and you will have message hello comma Alice exclamation mark. Now print will be executed. So you see this box indicate whatever is the output or print output. So when you execute this line, you will get hello comma Alice exclamation mark. Now you are executing return. So when you are executing return, you see what happens here. All right, when you are so next, just next to this, so you have a return value of hello comma Alice exclamation mark. Now when you press next, then Z will be assigned the value hello comma Alice exclamation mark. All right, and this is the end of this program. So this is how global scope and function scope works, and you see there is no function scope left. So all that's instance, it is called instance of a function, or when you go to class, then you will understand it better. So that is being erased from the memory. All right. Any doubt? Now in this case also, when you do no return statement, so when you don't have any return statement, in that case none will be returned. So you can see it again here. So when you say greet name, and I'll just write the same thing, message message is equals to hello comma space plus name plus exclamation mark, and then I'll say print message message message. Now I'm not returning anything. Now I'm saying name is equals to Shubham, and I'm saying Z is equals to greet name. Now when you print this, print the value of Z, then you will see it is none. So when you don't have a return value in a function, in that case it will return none. All right. So what is return? The concept of return statement in programming can be summarized as follows. It holds significance within a function. So always, or actually I meant to write this in different line 1, 2 and 3. So it holds significance within a function. So you need return is not defined outside function. So it is always in sequence with a function. Whenever there is a function, then only you can write a return statement. All right. Only one return statement is executed inside a function. So you can have multiple return statement. I'll show you one example. But once a return statement is executed, then the function scope is exited. So just see one example, it will be better. Suppose I am defining even or odd. So I'm defining a function even odd. All right, and we have suppose a number over here, and what am I doing is I'm just checking if number is number modulus 2 equals to 0, then I'm saying return. So let it be is even, right? Return is even, return true. You can also have else here. When you write else and you do return false. Now you see in this case you have two return statements over here, but whenever one return statement is executed, then the function scope is exited. All right, so you can see this with that um, uh, this Python tutor. So I'll just show you is even 5. So suppose I'm passing 5 and it will return false. All right, and you can see this when you do check the code, or sorry, the visualize this code, how the execution is being done. All right, so I'll just show you quickly. Print is even 3. All right, and we will visualize this. You see when you are defining it, just 1 minute, yeah. So when you are defining it, so first it is executed and you have defined a function. Then this print statement has a is-even function call. So first this is-even will be executed and then print statement will be executed. All right. Achha, is-even 3, sorry. 2. Yeah. So is-even 2, then is-even 2 will be executed. So 3 will be passed to this parameter. In this case, it is formal parameter. And then it is checking if the number is divided by 2 gives a remainder of 0 or not. In this case, it is not. Oh, sorry, we have passed 3, then else will be executed and false will be returned. You see, return value is false, and then print statement is executed and false is being returned. So once a return statement is done, then the function scope is exited. All right. So this was what I wanted to show you with this program. Right. So I have one program over here which defines a function, and this function checks, it takes two numbers and gives the highest common factor of this number. So this is mathematics, very school level mathematics. If you don't remember what is highest common factor, so you can have two numbers and it will check what is the highest factor which is common to both the numbers. So suppose you have a number 6 and 36. So you see 36, you see, I'm sorry. Yes. So you see 6 and 36. In this case, 6 is divisible by highest factor of 6 is 6. And in that case, 36 is also divided by 6. In this case, for these two numbers, 6 is actually the highest common factor. So I'll just show you quickly one program which I have written, and it has a function which checks what is the highest common factor. So you see over here I have defined a function compute HCF, and it takes two numbers. So you can have multiple parameters to a function. All right. And we have to pass these parameters in the function call whenever you call that function. And what it does is it takes the smaller of the number. So these are concepts of highest common factor, how you calculate highest common factor. So this is what the logic is here. All right. So if you are not getting it, you have to revise how we calculate highest common factor. Otherwise, it is just defining a function, calling that function and getting the return value of that function. All right. So I'll just go through it quickly. You have two numbers a and b. You have to see which is the lower number, because a factor cannot be higher than the number itself. In our example, we had 6 and 36. You cannot have a factor, say 10. So 10 is not a common factor. Suppose 10 is a common factor, but sorry, it cannot be a common factor. I'm saying if you have two numbers 6 and 36, 10 cannot be a common factor because 6 doesn't have a factor which is 10. All right. So you have to check which is the smallest number. That is why I'm saying small is equals to b if a. So this is a new kind of way I'm writing if else. We will talk about this when we talk about compound statements later on, and also when we talk about list. But you can do something like this in Python in one line itself. So you're just saying if a is greater than b, then whatever the value is, assign it to b, else assign the value a. So this is some compound statement in Python. You can do it in simple statements also. If a is greater than b, then smaller is equals to b, else smaller is equals to a. You can do that. All right. That is also perfectly fine. So I've obtained the value of the smaller number between the two numbers a and b, and I'm saying let 1 be the highest common factor. You see 1 is always a factor of any number. So I'm saying let 1 be the number. Now for all the numbers from 1 to that number, that smaller number, I am checking if the first number is divided by I and also second number is divided by I, and I am updating HCF. It will check again and again till the smallest number, and it will obtain the highest factor which is divisible by, which divides both the numbers a and b, because we have an AND statement, and it returns that HCF. So whenever you call this function compute HCF and pass two numbers, then you will have the HCF of that number. So this is actually the function definition. This is the function call. You see, this is the function call, and it returns. So this function call returns the HCF, and when HCF is being returned, the value of that HCF comes over here. All right. And we have already talked about format. So what it will do is it will pass this number 1 over here, whatever the value of number 1 is, whatever the value of number 2 is over here, and whatever the value of this function call over here. This 0 indicates the first, 1 indicates the second, and 2 indicates the third. If you change this 1, 0 and 2, the places of this, it will change accordingly. So if you place 1 over here, then number 2 will come over here, and 0 here, then number 1 will come over here. You can check. All right. So this is how you can define a function, call that function, and perform some task using that function. All right. We have talked about scope, but there are few concepts of scope which is important to talk about. All right. Then we will see that concepts here. So let me take all this and copy. Sorry. Let me do it one by one. Now you see, this is one code where you have one function which is f, and then we will not talk about this function right now, just we'll move on to the global scope. So then x is equals to 5, and we are then calling the function. So what it is doing is it is passing this value 5 to this function, and y takes the value 5. All right. Now you see we have defined x over here as 1, and I am incrementing x by 1, and print x I am doing. And over here also, when the function call is over, then again I am doing print x. So I want you to think. So you think like this, or you, if you have a pen and a paper, you draw the global scope and this function scope, and you see what the print will be before executing it. All right. So you can use pen and paper and draw this and tell me what will be this print and what will be this print. So I will write it like this: inside function, and over here outside function. If you want, you can unmute yourself and say outside function. All right. You can unmute yourself and tell the answer. See, I'll tell you. What happens is when you define this, so let me do that Python tutorial. It will be better. So you see, when we define this function, in the memory we don't have anything. The first line is executed, then there will be a global frame or global scope, and this function will be defined. All right. Whatever in the function, it is not executed, it is just defined in memory. Now line number 6 is executed, and we have x as 5. Now number 7 will be executed, and we have a function call. Then the scope of that function will be defined, and the value of y will be as 5. All right. Now next you see, this is what the function scope is. Now you see x is defined as 1. Now you see this x and this x is different because this has a scope of global scope and this has a local scope. Now x is incremented by 1, so x is 2, and when you print this x, you have 2 because you are printing it from inside the function. So whatever the value of that variable inside the function, that will be taken as the value of that variable. So you see inside function we have 2. Now the control comes over here. You see we don't have any return statement, so this will be none, so nothing will be done. All right. So this scope of that function is gone. Now you have print x. In this scope, the value of x was 5. Therefore we have printed 5 and not 2. All right. Is it clear? Why it printed 2 and not 5, and on the other way around, why it printed 2 and not 5?
Yes, sir.
All right. Now I'll give you another problem. Sorry. Now tell me over here. So I'll just copy it and I'll just follow along. Just 1 minute. Huh? It it will be better outside. You see, in this case, you have a function definition. The function name is g, and there is only one input to that function or one parameter. Now I'm defining x as 5 and I'm calling g and passing 5 to that function, and I'm printing x. You see, in this function x is not there. So I'm asking you a question, will this program give an error? Or
No.
if not, yes, it will not give an error because the global scope has precedence over local scope. So if in local scope that variable is not defined, then it will go to local scope and check if that variable is defined or not. And if it is there, then it will take the value of that global variable and use it in the function itself. All right, so you can just see this here, visualize it. You can visualize it here. This function is being defined, then x is defined. We call function g and pass 5. And now you see, when you print x, 5 is printed because in whole memory we have only one x which is in the global frame. That is why 5 is taken as the value of that x and it is printed. Again, when you say x plus 1, then 6 will be printed, and there is no return value, then none is returned. And then when you come back, then again 5 is printed and not 6, because whatever update you did not assign to x. All right, and you got 5, and this code is complete. All right, there is one more problem I have, this one. And when you do this, then you tell me what happens. All right, so just let me take this down. You see over here, what am I doing is, x is not defined in this function. X is defined in global variable, and I'm passing the value of x in this function. And now I'm trying to update the value of x. X is equals to x plus 1. So this is just the same as x is equals to x plus 1. And then I'm printing x. So suppose I have a print statement as well over here. Now tell me what will happen. Inside function, and this is outside function. Hello?
Inside will be 6, outside 5.
Both the values should be 6.
You may think that the value of x will be 6 inside the function, but that is not the case, because you see, you get an error. Local variable x referred before assignment. What this means is, it is just, this statement is just that x is equals to x plus 1. Now when you are trying to do this, what are you saying? You are saying that this x, whatever the value is, you update it and assign it to x. In that case, you are calling this function x, and the x is not defined locally. Moreover, you are updating the value of x. In that case, it will give you an error. So when you go line by line, then you will see which line gives an error. You can debug your code here, by the way, and debugging is just checking line by line. All right, so you see, it says local variable x referred before assignment. Just go back and see what happens. When it is defining the function, there is no syntax error. The function is defined as it is. Now x is assigned 5, h is being called, and y is assigned a value of 5. When this line comes, then you see, you are trying to assign the value of x plus 1 where x is not defined inside the function. In that case, it will say that local variable is referred before the assignment, and it will give you an error because that x was not defined and you are using that x to assign it to the value to x. If you say y over here, then it will not give an error. Just you check. If you give y, assign the value to y, not yz, let me do it z and z, then it will not give an error. Then it will execute as you wanted it to execute. Z has a value of 6 and then print is done. Inside print and outside you have 5. The error is not because you're calling X inside a local scope. The problem is you're assigning a value to a variable which is not defined inside the local scope. It is defined in the global scope, and you cannot access the variable or update the variable in the global scope. You see, when you go back and when you are updating over here, you're trying to update in the global scope, not local scope, and that is not what you can do in programming. I don't know about other languages. In Python you cannot do it because it is in the global scope, and you are trying to change the global variable inside a local scope without defining it in the local scope. That is why you are getting the error. All right. Was I clear or did I confuse you more?
Okay, sir.
Anybody else? Because this is important to know what the scope of a variable is.
Now it is clear, sir.
Anyone else? Pratibha?
Now it is clear.
Yes, thank you, ma'am. Vaishnavi, Ayush, Rahul, Gargi. Okay, I'll just comment this and move forward. Now you see, in earlier classes, I have informed you that everything in Python is an object. And when I say everything, then functions also comes. So function is also an object in Python. And we will talk about object a lot when we go to object-oriented programming. But over here, you just have to know that function is also an object. And similar to the passing of variables into a function, you can also pass a function to a function. What I mean, I'll show you with an example. All right. This will make things clear. You see, I have three functions: function A, function B, and function C. And in function A, I'm just printing inside function A. In function B, I'm just printing inside function B. And in function C, I'm just saying, sorry, in function C, I'm just saying inside function C. All right. And you see, there is a little bit change in the return statement. So in first function, I don't have a return statement. In second function, I have a return statement with Y. In third function, there is a return statement, but I have done a parenthesis. So what does it says? It is similar to a function call, right? So in return statement, first the expression is evaluated, right? And then return is done. So when you go back and when we try to get the even numbers, where is even number? Yeah, here. So you see, first this expression was evaluated and then the return either returned true or false. The whenever the expression is evaluated to a value, either true and false, then only returns that value. All right. So here also, this is similar to, not similar, it is a function call actually. And what happens is this function will be called, whatever the return value of that function will be, it will then return it to whoever called it. So this will be clear when you go through this. You see what I did print function A. So this is a function call first of all. Before print, this is a function call. So it will do the function call first. So it will go to the function. It will do whatever is in the body of the function. It says that print this thing. So it will print it and it will return none. So the return value of this call or expression, you can say, is none. So print will print none actually. You will see when I execute this. Let me execute this. You see, when I called this function, it went inside the function and it said print inside function A. So it printed inside function A. Now it returned none. So this statement actually printed none. All right. So this is none. Now the execution is here. So the control is here and it is saying evaluate this expression first. 5 plus function call B. So before evaluating this expression, it will first do the function call. So it will go to function B and pass the value 2. Now 2 is being passed. It will say print inside function B. So print, so it is printed C function inside function B. Now it returns y. So 2 was passed, 2 is being returned. So the return value of this call or this function call is 2. So 5 plus 2 will be 7 and print will then print 7. So you have 7 here. Alright, so this is done. Now over here you see what I did is inside print I have a function called function C, and what is being passed, the name of a function is passed. It is not a variable, it is not a data. The function is passed as a parameter. So just think of it as a variable for the time being. Suppose this is z. Oh, z is already here. Suppose this is m. So the value of z is m in that case. All right, it will behave as it is. So this function will be called with the value of z as m for the time being. Suppose it is m. Now it will print whatever it is there. So it will print inside function C. Now when it comes here, return z parenthesis. Now the value of z will come here. So what is the value of z? I'm saying m, but actually it is func a. So this will be func a parenthesis. So what is func a parenthesis? Func a parenthesis is actually a function called to function a. So the control from here will go here, func a. Now func a will be called. It will print inside function a. You see it prints inside function a. It doesn't have a return value, so it returns none. Over here it comes, it says none. Again return none. So overall this expression has a value of none. Therefore prints none. Right? Is this clear? You can visualize this using Python tutor. Is it clear? You see, just a minute. Over here you will see that there is 3 scopes. Actually it's nested scopes. One local scope has another local scope inside it. You will see what it means when you visualize this. You see, we will run it. First, the definition of function A. In the global scope, function A will be defined, then function B will be defined, function C will be defined. Now, first print will be executed. Before that, there is a function call. So, function A scope will be defined. You see, function A scope is defined. There is no variable, there is no parameter, so nothing is being passed. There will be print statement will be executed. So you see, print is executed. It is inside function A and the return value is none. Now when this return value is being given to this print function, print is also a function by the way. So when this return value of function A, which is none, is given to print, it prints none. And this scope is erased from memory. You see, this scope is erased and we have none over here. Now when we are here, print 5 plus function call B passing value 2, the control will go to function B and we will have a variable y is equals to 2. Now we will have a print statement inside function B and there is a return value of y, which is 2. 2 will be returned and this will be evaluated. 5 plus 2, then 7 will be printed. You see, 7 is printed inside. 7 is printed. All right, now this function call is there. Until now you already have only have a global scope and a one local scope, but over here you will see that you will have one global scope. Inside that there will be a local scope, and for that local scope there will be another local scope. All right, you see, first there is a function called to C. First there is a function called to C, so C will be called. Now this is being executed, so print inside C will be run, so it will have inside function C. Now when you come to this, then there is a function called to A, and you can see that this is one scope, this is another scope, and this is another scope. All right, and when you do next, then this will be printed. You see, inside function A is printed. Now the return value of function A will be none, so it will be returned to here. So the return value of function, if you go back, you see the return value of function A is none. It is returned to this expression. All right, when this expression is evaluated, you will have a return none over here. Now this none will be returned back over here. When this none is returned over back here, then the print will print none and the program is complete. Anything else? So for this class, I have this much. I don't have anything else for today's class. Yeah, so it was little bit more today. So doubt and questions or something which is not clear at all, you couldn't understand anything, was it difficult, was I not able to explain clearly, anything else, anything you want to tell me?
Sir, formal and actual arguments can be of same name.
Yes, formal and yeah, formal and actual argument can be of same name. We saw this, right? We saw this here when we were calling x, when we were calling x somewhere. Where were we calling x?
Name itself.
Over here, I guess. No. Yeah, we have done this. So
Name.
so you can do, yeah, name. Yes. Over here, you see, formal and actual parameter have the same name. All right, so I guess no doubt. So, and many of you have not submitted the assignment. So I would request you to do the assignment. If you don't want to submit, it is up to you. Don't submit. Plus, but please do the assignment. You will learn by doing, not by just watching my lectures or just uh, checking my lectures what it is happening. If you don't do or don't practice, it will just be like watching a YouTube video. You will just watch it and forget it in some subsequent days. Until and unless you practice writing code, you will not get the hang of writing the code. You will feel, yeah, I am understanding it, but you will not be able to do it yourself. All right, so I will request you sincerely to please do write code, solve problems. The problems which I am giving as assignment is not enough. You have to do many more problems to actually learn programming. All right, so it is 071023. Yes, so please tell your names. I see Ram Prakash. Ram Prakash. Yeah, Kalyavani ma'am is here. Next.
So serial number 3.
3. So should I call you Akhila or Shiv Yogi?
Akhila, sir.
Okay, sure. Thank you.
Thank you.
Amrita is also here. Ayush Shambhavi, Ayush is here. Ayush, are you here or have you left? No answer. All right. So I'll just mark Pratibha is here. Pratibha, hello. Hi, Pratibha.
Hi, sir.
You are here. Good. Vaishnavi, hello. Where is Vaishnavi? Rahul. I'm sorry, I couldn't hear you. Who was it? Gargi is here. Ranjit is here. Ranjit is here. Gargi. Vaishnavi, yes. Vaishnavi, I have done. Yes, thank you. Sorry, Gargi is here, no? Where is Gargi?
Shambhavi Mishra, I am also present.
Yes, thank you. Anybody else? Did I miss anyone? No, I don't think so. All right. And again, I'll say, if you want to call me Shubham, you can call me. There's no need to call me sir. All right. So how many are present? 11. All right. Thank you. Thank you for joining. And what I was thinking is, so we have talked about functions, but this is not complete. There is a lot more to talk about functions, inbuilt functions. But I was thinking to go to data structure first. We will see what is how data structures are used in Python and how it is made simplified in Python. Actually, we have list, dictionaries, sets, etc. And then maybe we can go back to functions and see more about functions. I'll see what the flow should be. An appropriate flow will be, I will see that it is appropriate for you to understand. All right. Thank you. So you can leave, huh? If you don't have any doubt. If you have any doubt, you can ask me now, others will leave. All right, I'll end them.
Thank you, sir.
Thank you.
Thank you.